Okay, so the topic for this video is going to be Newton's three laws. So now, the first law is an object will remain at rest or in uniform motion in a straight line unless acted upon by an external force. So this is basically saying that if this ball is rolling in a vacuumless space, so there's no air resistance or wind resistance at all, it's just the ball on the surface it's on, friction will eventually act upon it and will stop it from rolling. Now, what was first thought was that moving objects have a tendency to stop, so they would just stop on their own. And then it eventually developed into stopped objects. Eventually, had a tendency to roll if they were acted upon, which is what Newton thought and gave us our sense of object movement today. Now, the second movement, our second law, is a bit different. This involves mass. So now the second law is just force equals mass times acceleration. Now mass isn't necessarily the weight, but just how much there is of it. And so it's not asking for how much gravity is being asked or being forced upon it. So this is our little diagram we have here. But so let's say the force you're applying is 10 newtons, but this can also be written, you might also see it as 10 kilograms times meters a second squared, right? So let's say the mass of the object right here is 2 kilograms. And we don't know the acceleration. We're trying to find that. So what we just do is 10 kilograms of meters times meters per second squared is equal to 2 kilograms times acceleration. Now you just solve this algebraically by dividing by 2 on both sides, which give you 5 meters a second squared equals acceleration because the kilograms cancel out. And that's how you find the acceleration. So that's a pretty simple equation. Now for the third law is for every action, there's an equal and opposite reaction. So now here we have a person moving a cart. He's actually pushing it. It looks like he's pulling, but he's not. So now what he's pushing on is like a metal rod, right? So if that metal rod isn't strong enough, because how fast or the amount of force you're pushing onto that rod is being pushed back onto you, and if that rod isn't strong enough to support that much, it'll crumple. And as you're pushing it, your hands will compress. So now, as if you put your hand up against the wall, your hand will compress, as you can see. The wall is also pushing up against you. So those are the Newton's three laws.